science decrees that as our universe expands and ages, it will cool. Inevitably, the future for life as we know it will grow ever more hostile.
We are headed for a time when one day the universe itself will freeze to death, and all life with it. And that's a law. When we scientists look at the evolution of the universe, some critics say, that's crazy. We can barely predict tomorrow's headlines, and here you are, predicting what's going to be happening billions and billions of years from now. How do you do it?
Among the tools available to scientists pondering the future are the venerable laws of thermodynamics.
The first law says that total matter and energy are conserved. In other words, you can't get something for nothing. There's no free lunch.
So it turns out that the total amount of matter and energy in a system can be neither created nor destroyed. The matter and energy can change forms and they can turn into one another, but the total remains the same. So for example, in this rolled up newspaper, there's a lot of energy stored in the chemical bonds of the paper. But if I ignite the paper, I can activate those bonds and I can start breaking them, and that releases energy in the form of light and heat, which you can see and feel. The total energy content is still the same, but it's being dissipated out into space. And a lot of particulate matter goes off as well, and smoke goes off. But if I were to add up all the smoke and the particulate matter and all the energy that's given off and everything total, I would get exactly the same amount of mass and energy total as I had to begin with. They simply changed forms.
If the total amount of mass and energy remain constant, this seems to imply the universe will always have energy and should last forever. But the second law of thermodynamics crushes this notion.
The second law of thermodynamics is the most curious of all. It says that total amount of disorder or entropy always increases in the universe. In other words, things rust, things decay. Everything gets old and eventually falls apart and rots. In some sense, the second law is a death warrant for the universe. The second law says all things must pass.
The ever-present supply of energy in the universe inevitably becomes more dispersed, more chaotic, and more unusable. Each star burning in the sky, just like each briquette of this charcoal, must one day face its fate.
This piece of charcoal is fuel. It has a lot of energy concentrated into this small little packet here. The energy goes from being in the chemical bonds of the charcoal briquette to being liberated in the form of heat and light. Now, a star does a similar thing. It doesn't burn in a chemical sense. Instead, in a star, it's nuclear energy. The nuclei of atoms are being forced together, fusing them, creating new nuclei, and in the process, transforming some of that matter, some of that mass, into the radiated energy that we see and we feel. And the same process is going on in all the active stars in the universe. Now, as this charcoal is burning, the fuel is getting used up, and you can actually see that. It's turning into a gray color, it's turning into ashes. In a similar way, stars use up their fuel. They fuse hydrogen into helium, and so with time, there's less and less hydrogen to fuse, and the ashes have less energy content and thus are either harder to burn or release less energy during the burning process.
This is the eventual fate of our own sun. As it ages, it bloats and heats.
The Earth will be fried to a crisp. Oceans will boil away, all plants and animals will die, rocks will start vaporizing because the sun will be producing so much light, so much energy. That'll be a pretty gruesome death for the Earth.
All through the universe, stars that are like the Sun are going to be facing the same challenges that our own star will face. They're running out of fuel, they're swelling up, and they're causing problems for the planets that orbit them. So it's not hard to imagine that there are many locations where life has evolved and flourished and is now being extinguished.
Just as each star suffers the effects of entropy, so too will the rest of the universe.
But stars naturally increase the entropy of the universe by giving off light and heat, just like this fire of burning charcoal naturally increases the entropy of the universe.
Right now we're kind of in a steady period in the universe where stars are born, live out their lives, die. Give some of that gas back to the next generation, then you have another generation of stars.
But that rate of star formation is gradually decreasing with time. And as stars use up their fuel and burn out, there aren't enough new stars being formed to replace them.
But the moment we run out of gas to make new stars, it means for every dead star in the rolls, in the ranks, there's not a star to replace it. And so that's a bad situation to be in the day that happens.
So effectively, galaxies, giant collections of stars, are growing progressively dimmer with time on average. And eventually, when the universe is something like 100 trillion years old, there will be essentially no stars still shining. The universe will be cold and dark indeed.